be comfortable with long dividing now? Yeah? Okay, so long dividing, I just gave you the polynomial, gave you the binomial, and then you either do the long division or synthetic. And at this, you should know how to do both. I think most people probably like synthetic better. Am I right about that? Is there anyone who prefers the long, like kind of the traditional way? Yeah, you do? And you do? Do you want it? That's okay. This way, you have to use if you get something tricky, like if you had a 2x minus 1, the traditional way is the better way to do it, okay? So it's up to you, your preference on a test. I'm not going to ever tell you do it one way or do it the other. So everyone should be comfortable with this. I give you the polynomial, I'll give you the binomial. That's kind of easy now. And then what else? Then we learned about the remainder theorem, because what I kept telling you all along is we don't actually ever want to work with these. We only want the ones moving on forward. We'll only be able to graph the ones with 0 remainder, right? So that's what we talked about on Friday. It said determine the remainder when this polynomial is divided by this binomial. Okay? So the first two examples we got remainder 0. Now this is called the remainder theorem. The remainder theorem is a quick way to determine the remainder without doing the whole long division process. Okay? Now, this is one of the outcomes that you're kind of going to be tested on. So, you could have, someone could have said, oh, I prefer to do all the long division. I just wanted to long divide this whole thing to see if there was a remainder or not. That's certainly a strategy, but it's going to ask you to use the remainder theorem sometimes on a test. The exam, I've seen those questions on the exam. So if you did do the long division, you wouldn't get marks for it. You would still show me that there was remainder 0. But when you're asked to use the remainder theorem, this is what we want. We want you to plug the a value into the equation, right? Using the remainder theorem, is a quick way to determine if the remainder equals 0, which is what we want, right? Now this one, if I knew that it equals 0, I'd say, okay, yes, this a value is good, this binomial is going to be good, so what I would do is then I would go ahead and proceed with my long division, okay? This means this is a factor of the polynomial as well. And then I kind of stop there because moving forward, you have to really make sure your factoring skills are sharp. So then we kind of stopped, we put the brakes on, and we just reviewed some factoring techniques, right? Sometimes you can't do anything except just pull out the greatest common factor, the biggest piece that they have in common. This is a specialty type of factor. It's a squared, right? It's a quadratic, but it's a difference of squares. So this is also something I hope you haven't forgotten, difference of squares. And then we move to the most common type of factoring that you'll see, factoring that classic trinomial pattern. Either the easy polynomials with just an a of 1 or the complex trinomials. And you might have your own way of factoring. That's fine. You use whatever way is comfortable for you. This is the 5-step method or the breaking into parts method, the grouping method. So like I say, whatever way makes sense to you. Then I asked you to do some more review. So were there any questions on the homework at all? No? Hopefully you're doing it. When I ask you there's no questions and everyone just, I'm assuming everyone did it and had no questions as opposed to assuming that no one did it and had no questions, right? There's a difference there, right? So, and I know your lives get busy, but please, even if you're a little behind on homework, I don't mind answering older questions, like I might do it off to the side, but I'd rather you ask me questions even if it's from a week ago, right? You can either ask now or when I'm wandering around helping people. Okay, Well, maybe it is just that easy, right? I do find this a nice unit. Most students like this one. Okay, we're going to proceed. And also, everyone has the book, correct? The homework book now? Now, did anyone go online and create an account here and check out their extra questions? Okay, because it's on the front end. And I think every few pages they'll remind you, right? Like here, more questions at Math Help. You did? You created an account, Abdullahi?
PDF monthly fee.
It says create a free account though.
Yeah, but it's limited.
Oh, how much limited?
It's expended little bit.
Okay, I'm going to contact them and see if we get some kind of rate for buying all these books. There is lots of other stuff available, right? And remember, there's help in the library across the hall most days. I'm there every slot too, if you're around, like at 10 o'clock, 10 to 11. All right, so I am going to teach you or talk to you about the factor theorem today, but this book has lots of other, like I said, notes embedded that they talk about the factor theorem even more. So between my notes in class and like if you need more review, and I guess what I'm going to tell you now, sometimes I'm going to remember to tell you do some pre-reading, but when you know that I'm following this book pretty closely, like you can tell what topic I'm doing the next day, right, from these purple books too. If you look, like we're doing, tomorrow's lesson will probably get to relating the graph and the equation, right? So anytime you can pre-read a little bit, that's a good thing, right? Because then what I say in class will stick even more. So again, there's a little bit of a few notes in here, and we're going to proceed on with the factor theorem. So the factor theorem and the remainder theorem, they both have that word theorem. They're really closely related. Some students might even think that they're the same, but they're not quite the same. So it says, as we learned in the previous lesson, when we end up with the remainder of 0, we have found a factor of the polynomial. So when we have remainder 0, that's when we can go ahead and do the long division and start breaking that polynomial apart, okay? But the factor theorem goes a little further than the remainder theorem in recognizing what binomial you use. So what this says here, Chris, did you get a book? Yeah. You got a book, right? Like you got one of these textbooks.